Okay, so you guys can see the whiteboard, right?
Yes.
Yeah. Okay, so today I'm going to start on with uh, just a moment. Why is it not drawing? So I'm going to start today with the percentages and okay. So what exactly is percentage? Like if you actually get to the basics of it, percentages is simply trying to for us to be able to compare different things, right? Like you got 40%, I got 50%, even though our total number of marks are different. So what happens is GMAT, first of all, will ask you questions which would be just simply going from the English version of the question to the math version of the question. So it is going to ask you questions like if you have the word percent, that means you have to divide by 100. If you have the word of, that means you have to multiply, right? So what if you have the word what, that means you have to put a variable there, right? If you have the word is, or if you have the word equal to, that means you have to use the sign equal to. So similarly, if I like there would be many questions like what is x percent? If x percent of 80 is 100, then what is x? So what you have to do is, in those type of questions, you just have to use this vocabulary and convert the English question to a math problem, and then just go by the vocabulary, and it'll actually work out pretty well. So those are easy type of questions, right? So that's what you get, trying to find the percentage of something. Another type of questions that you would get is related to percentage change. Now, those can get a little tricky. So these are the questions where something is changing by a certain percentage. Now, what happens is, the way I perceive it, that if let's suppose if you change something by X percent, let's suppose if you increase something by X percent, what does it become? It actually becomes 100 plus X percent of itself. So if I say I have changed something, I have changed this number 70, I increase the number 70 by, let's say, 30%. So what will happen? That means 70 has become 130% of itself. This is what the percentage increase that has happened. That is the total change. So if you have a number, let's suppose if you have a number here, this number is whatever number is that here, let's suppose this number is X, and you do some percentage increase. Let's suppose you do an A percentage increase, and then you have the result here. Let's suppose the number becomes a Y. What is the process that has happened here? So X has increased by, X has been increased by A%, right? So that means you are increasing A, and then you're also adding X percent of A. That is what is giving you the Y. So that means what is happening is Y is equal to X into 1 plus A over 100. Right? So this is my expression of percentage increase, or for percentage decrease, you'll have a negative here. This is my expression of percentage change. Like you'll have many questions where they'll be asking you this in terms of variables, so you have to understand that. So if I say that I am increasing X, if I am increasing X by 2%, then what is the resultant expression? That means X gets increased by itself and then added 2% to it. So if you kind of try to understand what is this, This is nothing but 1.02. So if you increase x by 2%, x gets multiplied by 1.02. This is the multiplying factor, or whatever you want to call it. If you increase x by 3%, then x gets multiplied by 1.03. If you increase x by 50%, then x gets multiplied by 1.5. If you decrease x by 2%, then it becomes x into 0.98. Are you guys understanding what I'm doing here?
Yes.
Yeah. So this will actually make things very, very easy and quick for you. So if you see a question where you say, oh, there's a number and has been increased by 10%. Okay, there's a number that has been increased by 10%. And this overall number is now again increased by 20%. This again, it's increased by 20%. What is the overall change? So if you want to find the overall change, all you have to do is multiply this number, right? So what is 12 times 11? So 12 times 11 is nothing but 132. So this becomes x into 1.32. So the overall change has been 32%. Is that fine, guys?
Yes.
So remember this. So whenever there is a percentage change, this is what happens. 1 plus this over 100. This is exactly what happens. Now you will also get some questions about successive percentage changes. So in successive percentage changes, what will happen? Just like I did here, there were 2 percentage changes that actually happened. You had a 10% change and then you had a 20% change. And then the question was asking you what was the overall change. So of course, we found the answer here to be 32, and we had this calculation here. You can do the question like this way, but there is a straightforward way as well, that if something changes by A%, and then the other thing changes by B%. So you had X, you change X by A%, and then the resultant thing you change by B%. So if that happens, that means what is the overall change? Like just I said, what is the overall change? It was 32% here. Either you can do this, you can say X into 1 plus A by 100 into 1 plus B by 100. This is the thing that reflects the overall change. Or you can simply say that X has changed. And if you actually solve this, you would know that X would have changed by A plus B plus AB by 100. This is the overall percentage change in X. So if you kind of use this example here, if X changed by 10% and X changed by 20%, so 10% plus 20% plus 10 into 20 by 100, which is equal to 32% change. And if wherever there is a percentage decrease, you have a negative there. If both are percentage decreases, then you have 2 negatives there. This will actually become positive, right? So if I say I give you a discount of 20%, on that same price I give you a discount of 30%, what is the overall discount? The overall discount is negative 20, negative 30, positive 20 into 30 over 100, which means that the total discount was negative 44. So the total discount was 44%. Did you guys understand this?
Yes.
Yeah. Lakshmi, is it okay? Do you have any questions?
Yeah, you talked about discount and all, right? So, so it became 20. So, just checking. Can you just tell once again? That would be better.
Which one? The successive percentage changes or the example?
Yeah, the last one. Yeah, that one.
Okay, so I gave you a 20% discount and then I gave you a 30% discount. There are 2 ways you can solve this problem. You can say, okay, let's say that first we got a 20% discount. So whatever we had got multiplied by 0.8. And then we got a 30% discount. Whatever we got multiplied, it will get multiplied by 0.7. So overall, it will get multiplied by 0.56. If anything gets multiplied by 0.56, what is the discount? 44%. Right? Another way of doing it is using this expression. So it is negative 20 and negative 30, and negative 20 into negative 30 over 100, which actually is also 44%.
Okay, yeah, now I got it. Yeah, thanks.
So that is one thing. Now so whatever we have learned, let's actually try to see the applications of that, right? So this is all about percentage, but there are a lot of applications that come out from here. So the first application of this thing is profit and loss. So we'll do the applications of percentages. First is profit and loss. Nothing changes. It's just the context that changes. So if I say, now in profit and loss, there are three things. Now understand, in percentages, there is always a base to which the percentage is applied, and then you get the final product. The only thing is identifying to which this percentage is applied. So if I say 10% of all your grades, so all your grades is the base. So the base, identifying the base is very, very important. So in profit and loss, you have the cost price, you have the selling price, and you have the marked price. So if you actually go to a shop, you have $100 written on the t-shirt, so that is the marked price. They give you a discount, they sell you for $90, that is the selling price. And whatever they costed them, that is their cost price. So so there are different percentage changes. So there is 1% change from here to here. There's 1% change from here to here, and there is 1% change from here to here. So from cost price to selling price, if you change anything, that is your profit or your loss. From cost price to marked price, it is your markup. And from marked price to selling price, it is your discount. So that means scenario number one, if you go from cost price to selling price, that means you're increasing your cost price by P% or decreasing it by L%. So that means the expression is that selling price is equal to cost price into 1 plus or minus profit or loss over 100. Now, I don't want you to understand, remember this expression. I want you to understand what is happening. We're actually using a percentage change expression here. The percentage change expression is that whenever X changes by A%, the resultant Y is X into 1 plus A by 100. And that is exactly what I'm doing here. Whenever you change the cost price by P%, the resultant selling price is cost price into 1 plus P over 100. Does that make sense, guys?
Yes. So when it is loss, it would be minus?
Yes. Yes. Is that okay?
Yes.
Priyanka, is that fine?
Yeah, that's fine.
Okay. Second thing is it's going from like cost price to the marked price. So whenever you go from the cost price, if you actually made something for $70, you mark it up by certain percentage to actually make it $100. But again, understand the base of that percentage is the cost price. You're going from here to here, right? So so here marked price, which is the final product, is cost price into 1 plus markup percentage over 100. And similarly, you have the third thing, which is the discount. In discount, you apply the discount on the marked price, not on the selling price. So you go from here to here. So marked price is equal to selling price. Sorry, the other way. Selling price is equal to marked price into 1 minus discount percentage over 100. So if I say, so if you actually want to understand here, your cost price is $70, your selling price is $90, and your marked price is $100. Let's say I want to ask you what is your profit percentage. So profit percentage is going from here to here. So that is that means you want to find the percentage increase from 70 to 90. So the base of that percentage is 70. So it is going to be the change, which is $20, divided by the base, which is $70 into 100. So that will give you your percentage change. Okay, guys, am I making sense here? Is that fine?
Yeah.
Lakshmi and Ryan, is that fine?
Yes.
Okay, let's move on to the next application. Application number 2 is basically percentage. It is growth. Now, there are two types of growth that they will ask you in GMAT question. The first type of growth is arithmetic progression. So in what happens in arithmetic progression is, this is not like really a application of percentages. Actually, the other type of progression is, but I will cover that as well here. So in arithmetic progression is, the numbers are equally spaced. You start with number A, the next number is A plus D, the next number is A plus 2D, and so on. So what is going to be the last number? It is going to be A plus, as you can see, there is one less here, A plus n minus 1 into D. That is going to be the last number. Very important expression. So this is what the general structure of an arithmetic progression looks like. So what we learned that when the numbers are in arithmetic progression, their average is the first number plus the last number divided by 2. This is something that you would be using a lot of times, right? So this is the average. If you multiply the average by the number of terms, what do you get? You get the sum of the numbers in arithmetic progression. So sum is nothing but, if you actually solve this, this is n by 2 into 2a plus d into n minus 1. You can either remember the expressions. I did this so much in high school that I will remember it for the rest of my life. Or what you can do is you can understand in arithmetic progression, the average is first number plus last number divided by 2. And if you want to find the sum, what you do is you just multiply the n number of terms and get the sum. Is that fine, guys?
Yeah.
Yeah.
Okay, let's move on to the next type of progression, which is compound progression. Now, unlike here, where numbers are equally spaced, you actually increase by the same number. Here, you increase by the same percentage every term. So if I have X dollars in my account, next year, it will increase by Y%. So next year, it will become 1 plus Y by 100. What will happen next year? This whole thing will increase by Y%. So then it will become 1 plus Y by 100 into 1 plus Y by 100, which is square. Third year, it'll be cubed. Fourth year, it'll be fourth. So that means my amount that I will get at the end is going to be the amount that I invest initially, which is my principal, and it will keep on increasing by R% every year for T years. So this is the expression basically. But there's nothing have changed. Still, y is x into 1 plus a by 100. Still, I'm doing that. This is just an application of it. That is, if I keep my money for R% and after T years, how much will that money going to be? So that is what the expression gives you. Now, this R% is nothing but this is your rate per annum. So that is your rate every year. Now, questions might give you this rate in a different way. The question might give you, let's suppose your rate per annum is 10%. That is, every year your money increases by 10%. But if I say no, your rate is actually, let's say, 10% every 6 months. So now your time has changed. That means what has happened is that now you're increasing your money by 10% every 6 months. So here, what will happen is, if I say what will be the money after 2 years, so that means you will not have TS2, but you have actually TS4, because there are 4 6 months in 2 years. Am I making sense here, guys?
Yes.
Lakshmi?
Yeah, but I think if you can tell it again, compound progression.
So if I give you, so there is a certain vocabulary of the way I actually give you my rate. So if I say my money changes 10% per annum, so that means your rate is 10% every year. Your money increases by 10% every year. If I say 10% per 6 months, that means your money increases by 10% every 6 months. How much does it increase every year? It's 10 plus 10 plus 10 into 10 by 100. Actually, every year, it actually increases by 21% in a year, because it's every 6 months, it's increasing by 10%. So in the whole year, it will increase by 21%. Is that fine?
Yes.
Now, I could have the same different vocabulary. I could say your money is 10% per annum, but it is compounded semi-annually. Now, this is a little tricky. Now, here what happens is, that means I have the rate as 10%. It is compounded semi-annually. That means my rate is actually 5% for 6 months. Now, this is just some accounting language. I don't see any sense in it, but that's how they do it. If I say the 10% per annum is actually compounded semi-annually, that means it's 5% for 6 months. That means what is going to be, is it going to be for overall year? It is going to be actually 10.25% per year. Is that fine, guys?
Yes.
Yes.
Okay. So what I've done is I've actually done two concepts here. I've shown you compounded progression. I've also shown you compound interest. So they both basically go hand in hand. They're actually the same. Now, if I want to give you the general expression of compounded progression, this is how it goes. So you have something as X with you, or let's say you have something as A with you. Every time it increases by R%. So you have 1 plus R over 100. And then the next time also it increases by R%. So you have 1 plus R over 100 raised to the power 2, right? So that's just compounded growth. Another type of compounded progression is where you have A, and the next number is A into R. You multiply by R every time. Instead of calling it changing by R%, you're just simply saying you're getting multiplied by R every time. That is the multiplying factor. The next time is A to the power 2. The next time is A to the power 3, and so on. So what is the nth term? That is A to the power R n minus 1. That is the nth term, right? Yeah, and you don't need to go beyond that. That would be just the way to do it. Any question here, guys?
How complex does compounding interest get in on the GMAT? Like, is it just like how you showed previously, like, you know, the semi-annually and finding that, or does it go into the nth term as well?
It can even ask you quarterly. So if it asks you quarterly, if I say 12% interest per annum, which is compounded quarterly, so then your rate is actually 4% per quarter. So then you actually go by quarter system. So if I say I invest $100, after a quarter, it is going to be this. So basically, after a quarter, it is going to be this. After 2 quarters, this. After 3 quarters, this. After 4 quarters, this. So this is what happens to it after 1 year. Does that make sense?
So 3%, right?
Oh, yeah, divided by 4. Sorry. I do that every time. 3%.
Okay.
Yeah.
Okay.
Yeah.
Another one, but not for compounding interest, for percentages in general. You know, when the questions are like word problems, sometimes when it's consecutive percentage in that question, I get confused about which base to use as the number, like which is the original.
Yeah. And that is actually actually going back to the real basics of percentages, which I started with. It's using the language. So using the language, you can understand which one is the base.
Okay.
Yeah. So we will do a lot of questions once I'm done with this. Yeah. right? So one last thing that I'm left with is, since I've already done the compounded interest, there is something known as simple interest. Now, simple interest is an application of arithmetic progression. Just like compounded interest, it's an application of geometric progression or compounded progression that we just did. So this is an application here. So here you invest P dollars. The next time it just increases by R%. So it's P plus R over 100, right? So the next year also you will add the same amount. You will again increase by R% of this. So next year what will happen is you will just have P into R plus RP by 100 and RP by 100. So you have 2 RP by 100. So what is happening here is every year you are adding your value by R% of P. That is what you're doing. Unlike compounded interest, where you had P, next year you increase this by R%, right? Next year you increase this whole thing by R%, and then the whole thing by R%. Here what you're doing is you're just adding R% of P every year. So the expression that turns out to be here, if you actually take a close look here, the amount that you get at the end of T years is actually principal plus rate into time over 100. That is what you get. You can see that. Like there's a 2 here, there's a 1 here, there'll be 3 there. So this is the amount of that you get after T years. And similarly, if you want to find out the interest, which is and across T years, that is going to be principal into rate into time over 100. Because every year you're going to get P into R over 100. In T years, you will get P into R into T over 100. Does that make sense, guys?
Yeah.
Lakshmi Narayan, is that fine?
Yeah.
Okay. Now let's actually get to some questions so that we can understand. Okay. Okay, one more thing that I need you guys to understand is it's actually trying to make your calculations quick. So like if I say I increase something by 50%, right? So what you can say is, you can say, okay, I actually increased something by 50%. It is going to get multiplied by 1.5. That is simple, right? Now sometimes I say, if I increase something by 14.28%, right? Now what is 14.28, right? You would know, but I know that 14 by 28 is 1 by 7. And try to learn some fractions from percentages, because they are regularly used. So like for example, half is 50%, 1/3 is 33.33%, 1/5 is 20%, and 1 by 7 is 14.28%. Just learn these fractions, and then you can actually have more fractions coming out of it. So if I say I change something, I increase a number by 33.33%. So that means you're increasing something by 1/3. If you're increasing something by 1/3, so what does number get multiplied by? That number gets multiplied by 1 plus 1 by 3. So basically that number gets multiplied by 4 by 3. So if you want to increase 60 by 33.33%, simple, it's 60 into 4 by 3. That is your overall change. It actually becomes 80. You guys are understanding what I'm saying here?
Yeah. Are these the only ones? I mean, are these the main ones, or should there be other ones that we kind of learn?
So if you know 1/3 is 33.33%, you would know 1 by 6 is half of it, which is 16.66%. But yeah, GMAT will not go beyond that. GMAT will just keep, I would say GMAT will just keep these. They don't test calculations that much, but this will just make you quicker. That's what it is.
Okay.
Lakshmi Narayan, is that fine?
Yes.
Okay. Yeah, I will go. I've done that. Profit and loss, compound interest. Okay, let's start with the easy questions first. Okay, here it is. So this is a very easy question. Why don't you guys solve it and we'll discuss it. Very easy question. So did you get the answer, guys?
Yeah.
Lakshmi, did you get the answer?
Yeah.
Okay.
I got you.
So you just have to convert the English to math. So you have X%. Wherever you see the word percent, that means divide by 100. So X% of means you have to multiply of Y is means equal to 10. So that's what it is. Then the next one, Y% of 120 is 48. So yeah, so you have these two equations now. All you have to do is get the value of X. So you can do that here. Y is 40 and X is just 1000 over 40. X is 25. Okay, did you understand this, guys?
Yeah.
Okay. Yeah, so all right, let's go with this. We'll increase the difficulty levels slowly and slowly. Okay, so what is the answer?
120. 120.
So stereo was marked down by 30% and sold for. Okay. Is 84 the base or 84 the product? Let me know. Is it the base or is it the product?
I don't understand. It's I just put it as equal to 84, the equation.
Yeah, so like so 84 is the selling price, right? It's sold for 84. And the question is actually giving you marked down. So the stereo was marked down and sold for $84. So the discount percentage, this is what is giving you. The discount is 30%. Now you have to find the marked price. And so what happens is, that means your marked price got down by 30% and then you got $84. That means your marked price is 84 over 0.7. Okay?
Yeah.
Lakshmi Ryan, did you understand this?
Yeah, but I didn't get the answer correctly.
Okay, but did you understand what I did here?
Yeah, can you come again once?
So what I'm saying here is that the price was marked down by 30% and then sold for $84. So you had some price, you had a marked price that got marked down by 30%. That means 70% of it remains, and then you got sold it for $84. So that's the equation.
Yeah, I got it. So I was trying to put it in setting price at 84 is equal to
Yeah.
become the same MP into 1 minus 30 by 100.
Yes. But yeah, I mean, that is also another way of doing it, like completely relying on the mathematical formulas. So here you had the what is this? This is your selling price. Selling price is 84. Your discount is 30%. You just have to get the mark price. So mark price into discount percentage actually gives you the selling price. So mark price into 0.7 is 84. Same thing. Is that okay?
Okay, got it.
Okay, why don't you guys do this? It should take you like 20 seconds. So what is the answer?
So just 103%.
Okay. Lakshmi, what is the answer?
And now I tried to put it in the formula, I got 4%, I don't know.
Okay, so there are two ways of solving this. First way is that what I want to tell you is whenever the question asks you the answer as a percentage, that means what you can do is you can choose your own number. Very important. So the population increased by 6%. Let's assume the population was 100. Okay. So then the population increased by 6%. It became 106. Then it decreased by 3%. That is 106 into 0.3. And then you will try to see the percentage change here. Another way is just using the expression that we have. Increase by 6% and then decrease by 3%. Then you had plus 6 into minus 3 over 100. So you had 3 minus 0.18. So the answer is 2.72. Did you understand this, guys?
I tried to do this. I just took some variable as x, and it was 6%. So I multiplied it by 1.6.
1.06.
Oh, so okay, 1.6 is 16%. Sorry.
1.6 is 60%.
60.
Yeah, you say 1.6, that is 60%.
That's a mistake I did.
And then you will multiply by 0.97, and then you will multiply these two things and try to, and then you would get something like something that will actually show you that is a 2.72% change. Like you will get 1.0272.
Okay. Yeah, so I took a little, like calculation oriented.
Yeah, and yeah. That's a very common mistake, and once you make it, you will understand it. Yeah.
Yeah, I got it. Thanks.
Okay, so let's move on to this number. So what is the answer, guys?
I got 1.28y.
Okay. Lakshmi, did you
I
get
got 1.28.
Yeah. So a 20% change and then a 60% change, and the overall will be 12. So you would have decreased by 20.
I just did a 0.8 into 1.6. Would
Yeah,
that be
so
correct?
that's
Minus
0.8 into 1.6 will also give you the answer. This will also give you the answer. Right. So that would be 40 minus 32. So 12, which is 30 minus 2, that is 28%. So it's 1.285. Right? Okay, great. Now let's get to some complex problems. Okay, let me do this one so that you can understand, you can get the gist of it. So what is the answer? I mean, just give me the expression. You don't have to give me the whole thing.
100 plus 2 over 100 to the power of 3.
100 into 1.2 raised to the power 3.
Yeah.
Right. Lakshmi Ryan, that's what it is, right?
Yeah, that's what I think.
Yeah.
I just tried to put directly into the formula what you gave last time. So, I mean, in the previous slide. So this is what I'm getting.
Yeah, try to take more organic approach. Like, I never see this question as a compounded interest question. I just see the question as a percentage problem. Right? Okay, let's get to some good questions on percentages. I'm just trying to find percentage problems. Okay. Okay, do you guys see the question on the board?
Yes.
Okay, so now we're getting to GMAT problems. Okay, why don't you solve this one?
Looks like I got an obvious answer. The last one, the E.
Okay, Priyanka, did you get an answer?
No, I need more time.
You still doing it?
Yeah.
Okay, yeah. Take a minute, yeah. In that time, Lakshmi, you can verify your answer.
Yeah, I got E as well.
Okay, so X% of Y is increased by X%, right? So yeah, you guys were correct. That was the answer. And so that's one way. Another way is you can choose numbers, but I think here using algebra is much faster because you have the tools to solve this kind of problem.
Because I plugged in, but I guess that takes much longer.
Yes, that is also true. Okay, let's see another problem. Okay, we'll get to the harder problems now. Okay, let's do this one. Did you get the answer, guys?
I got 2.10. I don't know. Maybe it's not correct because that 5% thing I'm unable to take it into proper consideration.
Okay, Priyanka, did you
I'll go with 0.63.
come again?
0.63.
Okay. So manufacturer's retail price of a certain item is $60. So MSRP is $60. Store A sells the item at 20% more. So store A sells it at $72. The regular price of item at store B is 30% more. So this is 1.3 into 6. Store B sells it for $78. But the item is currently on sale 10% the regular price. So the item here is 10% the regular price. So that is 78 into 0.9. And then if the sales tax is 5% on both stores, so 72 into 1.05 into 1.05. What is the result when the total cost of the item at B is subtracted from the total cost of the item at store A? So we just have to find the subtract. We just have to subtract these. So 78 into 0.9 into 1.05 minus 72 into 1.05. What you can do is you can take the 0.1.05 out. You're just left with 78 into 0.9 minus 72. 78 times 9 is 9 times 8 is 72. 9 times 7 is 63. 70.2. 1.05 into basically 72 minus 70.2. What do you get? 1.05 into 1.8. Right? Is that what you get? Yeah. So 1.05 into 1.8. I'll have to check that. That is going to be so how would I do that? Okay, 1.05 into, okay, I actually use some technique here. 105 into 20 minus 2. Let's do that. So 105 into 2 is 210, and 0 minus 105 into 2 is 210. So it's 2100 minus 210, which is 0, which is 9, which is 8. This is 1. Divide that by 1000. 1.89 is the answer. Okay, did you guys understand what happened here?
Yeah, I did everything correct, but 1.05 thing, I if I would have added it here, then I would have got this answer.
Okay. Okay. Priyanka, did you understand?
Yeah.
Yeah.
Is this an actual GMAT question?
Yes. Yes, it is. Yeah.
Okay.
So did
because of that 1.05, I just guessed it between 2 and 1.9.
Okay. Okay. Did you guys also see the way I actually multiplied this?
Yeah, can you show that again?
So,
but it takes little more than 2 minutes, right?
I mean, if I was not explaining you, it would have taken me 1 minute, right? So I was quickly down to this and then down to this. So the way I multiplied this was 1.05 into 1.8. I took it as 105 into 18, and I took it as 105 into 20 minus 2, which is 2100 minus 2110, which came out to be 1890. And then I just divided it by 1000 because of 2 and 3. So it came out to be 1.1890. Okay.
Okay.
Yeah, got it. Thanks.
Yeah. Let's get to some difficult problems now.
And it says the sales tax is 5% of the purchase price on both the stores. So so it will be the same. I mean, what I did was I just ignored it.
No, you should not ignore anything given in the question. Right? Is that fine?
Yeah. So anything that is taxed, so we have to subtract it, something like that.
Depends on the way the tax is given. So if it's given in terms of usually you always add to the tax. If something costs $100, if tax is 5%, you add 5% to it. Sometimes the question might be such that you're supposed to deduct tax, like reduce as a tax. So you have to understand the context of the question. Okay.
Okay.
Yeah. Try this problem. If you're done, let me know.
Done.
Lakshman, did you get an answer?
Got C.
I got D. I don't know.
Okay. Okay, so it says the total cost of producing item X, it's equal to the sum of X fixed cost and variable cost. If the cost of producing X decreased by 5%, the total cost of producing item X is equal to the fixed and variable. The variable decreased by 5%. Okay. So cost of X is the fixed cost plus the variable cost. So if you produce, let's say, X units, and this is variable cost per unit. That's the expression. Now, if the variable cost of producing X decreased by 5% in January, so now it became 0.95 V, by what percent did the total cost change? So now the new cost is F plus X into 0.95 V. You want to find out the percentage change. By what percent did the total cost? We have to find out the percentage change from here to here. So what is the percentage change from here to here? That is this minus this. So that is going to be basically X into 0.95 V minus X into V divided by the base, which is F plus X into V into 100. That is the percentage change. So if I get F in terms of V, I'm golden, because then V will cancel out. And of course, X, there are a lot of variables here. Let's actually see what do we get. First statement says the fixed cost increased by 13%. If the fixed costs also increased by 13%, still I do not have the answer, because still my expression is going to be this. F will just become 0.13 F, right? Sorry, F will just become 1.13 F plus XV. Sorry, sorry, not about that. It will be 1.13 F minus F plus this whole thing divided by this thing into 100. So still it will not give me the answer. So this is not sufficient. So it's either answer option B, C, or E. Let's look at the second one. It says before changes in January, the fixed cost of X, producing item X, was 5 times the variable cost of producing the item X. Now this is good, because now cost of producing X now is 5V plus XV. That is the cost of producing the items. So now it says that the variable cost has reduced by 5%. So if the variable cost is reduced by 5%, so now it is just 5V plus 0.95 XV. So now what is happening? I'm just making sure that it's not telling me that the fixed cost has also changed. No, it has not. Okay, so now percentage change is just this minus this over this into 100. So that is going to be same thing, which is X into 0.95 V minus XV divided by this thing, which is 5V plus XV into 100. Now, are you able to solve this expression? The V would actually get cancelled out, right? But the problem here is going to be this. You will not be able to cancel out how many units are you producing. Like, you don't know how many units are you producing. So this number of units can actually change the answer. So you have 0.95x minus this x, that is 0.05x divided by x plus 5 into 100. So it will still depend on the value of x, right? And you don't have the value of x anywhere. So that means this is also insufficient. But if you combine both the statements, actually, even if you combine both the statements, still you will not get the answer, because you do not know how many variables, how many units were produced. So to me, it looks like answer is E. Okay, guys, your take on this.
This went totally above my head, and I got it completely wrong. So the problem was when I took x fixed and x variable, and then x variable that was given was xb, which was 0.95, and the first statement said it increased by 13% in January. So to me, it appeared it was sufficient. I don't know. Can you please explain it once again? I totally got it wrong.
So I mean, if the fixed cost changes by 13% and the variable cost changes by 5%, you still don't know how many units of you're producing, because if you know how many units you're producing, then only your total cost is actually a function of your fixed cost, it's a function of your variable cost, and it's a function of how many units you produce. So you don't know the number of units you produce. And even if you actually go by the expression, the percentage change is going to be 1.13 minus F. I mean, the percentage change is going to be change in fixed cost plus change in variable cost divided by fixed cost plus variable cost into 100. So you have.
Is it not talking about only one item X? So, should we really consider about number of units, or it's just one unit, right?
Okay, so if you consider it to be one unit, then the second statement is sufficient. If you consider X to be 1, then the second statement is sufficient. But it's not telling me here. I mean, variable costs.
It says cost of producing item X. So
actually, if you understand the nature of variable cost, the nature of variable cost is that it depends on how many numbers of units you produce, or the amount of inputs that you have.
The item X, what I could perceive was like it's one item. So I think it is like, I don't know.
Yeah, it should have given it in the question that item X means item X. Yeah, if you take that thing, then of course B would be the answer. If you actually take that thing, if you assume X number of units to be produced as 1.
And what about first statement?
First is insufficient because you have fixed cost changes and you have variable cost changes, and they're different changes. Your percentage will just not come out if you actually try to calculate the percentage change. Like let me sorry. Like now my fixed cost is changing by 5% and my variable cost is changing by 13%. So my percentage change is what? My percentage change, if I'm assuming there's just one unit, my percentage change is fixed costs. So that is going to be 0.05 fixed cost plus 0.13 variable cost divided by fixed cost plus variable cost into 100. That is my percentage change. So that will not give me the answer.
Okay. Got it. Thanks.
I'm not understanding why B is sufficient for even if it's a one item, because you still don't know how much the fixed cost has changed by, what percentage it's changed by.
So you're talking about the second statement?
Yeah, you said if it's one item, like B should be sufficient, right?
Yes, because now it is telling you fixed cost in terms of variable cost. So if it was one item, then your overall your cost is going to be 5 times the variable cost plus the variable cost.
Yeah, but you don't know how much. It says like it was 5 times the variable cost before the changes in January.
But percentage change, the way the percentage change will work is the variable cost and the variable cost will cancel out. You'll only have the percentage change. So you have your cost is 6 times the variable cost, but if you are again, what has happened to the variable cost now? The new cost is 5 times the variable cost, which is the fixed cost plus variable cost into 0.95. You will still, if you divide this by this, V will cancel out everywhere, and you have just numbers. Okay. Does that make sense, guys?
Yeah.
Yeah. Okay.
Yes.
Okay.
So how difficult was this question as per GMAT?
This is a 700 level question.
Okay.
Yeah. Okay, I'm gonna pick up a question now. Okay, let's try this one. So did you get the answer, guys?
I think it's, I'm not sure, but I think it's E.
Okay. Lakshminarayan, what did you get?
I'm confused with B and E, but if I were to choose, I'll choose E because the percentages. Anyways, yeah.
Okay. So whenever you get this kind of problem, always create a table like this. So you have people who are 65 year or older employed. So you have two things happening here. You have people who are employed, you have people who are unemployed, you have people who are above 65, and you have people less than 65. Always do that. That is very, very helpful. Okay. So at least 10% of the people in the country who are 65-year-old are employed. So the question is asking who are 65-year older employed. So 65-year older and employed. So the question is asking you this. Okay. Let's see the first statement. So you again have greater than 65, less than 65, employed, and unemployed. So in country X, 11.3% of the population is 65 years and older. So that means this is 11.3%, the total of 65, right? So you have the totals here. In country X, 11.3% of the population is 65-year-old or older. So this is 11.3. So that means this can be less than 10 or greater than 10. So definitely not the answer. Insufficient. Let's look at the second one. In country X, of the population of 65-year-old or older, 20% of the men and 10% of the women are employed. So here in the second question, it says that 20% of the men are employed and 10% of the women are employed. Okay, that makes it interesting. So here, it's just talking about 65 year and older. Everywhere it's only talking about 65 year and older. So I'm going to change my table. I'm going to say men and women, employed and unemployed. We're just talking about people who are 65 year and older. So we want we want to know whether the total employed is greater than 20%. So it says that 20% of the men and 10% of the women are employed. So 20% of the men and 10% of the women are actually employed. So 20% of this and 10% of this. Okay. So does that mean that the total 10% of this are employed or not? So if let's suppose this is X and this is Y, this is X plus Y, this is 20% of X, this is 10% of Y. We want to know that is this at least 10% or of X plus Y. So what is this? This is 20% of X, which is X over 5 plus Y over 10. Is that at least greater than or at least equal to 10% of X plus Y? Right? Is that what the question asking? At least 10% of the people in country X who are 65 year older and employed. So that is what we need to know. What is this? This is into 2 and this is into 2. So this is 2x plus y over 10. Is that at least greater than x plus y over 10? Looks like it, right? Because x is always positive. That is always going to be greater than, this is always going to be greater than x plus y over 10. So that means B is my answer. You guys getting what I'm saying here?
Can you go over the second part again?
So, okay, I'm going to clear this. I'm only going to focus on answer option B. So it says that in country X, of the population of 65 year and older, 20% of the men and 10% of the women are employed. So So let's suppose that there are X men, and let's just say there are M men, and let's say there are W women. So how many men are employed? M over 5. How many women are employed? That is W over 10. So the question is asking me, is this greater than at least 10% of the whole people? So 10% of the whole people is M plus W over 10. So that is what the question is asking me. So the question is asking, is M over 5 plus W over 10 greater than M plus W over 10? So what is this? This is 2M plus W over 10. Is that greater than M plus W over 10? Now I'm assuming that M is greater than 0 and W is greater than 0. If I'm assuming that, then yes, it is always true. This is sufficient. Let me know your questions, your thoughts.
Why is it, sorry, why is it M over 5?
20%? 20% of yeah.
Because I just assumed, like, I thought this was sufficient, and then I just took really big populations as samples, like 1,000 for men and, you know, for women, and then tried to calculate. I just assumed that it wouldn't be 10% if you take like a larger sample size.
Okay. In data sufficiency, don't go with numbers. Try to keep variables in there, because when you put in a number, you're putting in an assumption on your structure. So yeah. Lakshmi Narayan, did you understand what happened here?
Yes, I did the same mistake. First, I took 20 and 10 in simple calculations. It was okay,
Okay.
and then if I took big numbers, getting the answer was difficult. So I took E.
Okay. 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 So yeah, try to go all the way in your data sufficiency problems. Never assume things. If you want to discard a statement, say this statement is not sufficient, always try to find the reason for it. Okay, let's see this one. Did you guys get the answer?
Is it B?
Okay, Priyanka?
Don't know. D.
Okay, so it says that in 1999, company X gross profit was what percentage of its revenue? So the question is asking profit over revenue. So what is profit? Profit is revenue minus costs over revenue. That is what we want. First statement says gross profit was 1/3 of its expenses. So profit is 1/3 of the cost. So if profit is 1/3 of the cost, so that means, okay, let's see, company X profit was what percentage of its revenue? So profit is revenue minus cost, and profit is 1/3 of the cost. Profit is okay. Gross profit is 1/3 of its expenses. I'm just thinking here. I still don't feel that this is insufficient. So I'm going to take an example. Let's say that the cost is $3, then the profit is $1. Okay, so if you know the cost, if you know the profit, there's also another thing that revenue minus cost is equal to the profit. Then revenue is profit plus cost. So what is revenue? Revenue is profit, which is 1/3 of the cost plus cost. So the revenue is 4/3 of the cost, right? So you can get this expression, which is R minus C, which is R is what? R is 4/3 of C minus C over 4/3 of C into 100. So you would get C will get canceled out and you will have an answer. So this is sufficient. Did you guys understand what happened here?
Yes.
Lakshmi Narayan, did you understand?
Yeah.
So it's another one. It says expenses were 3/4 of the revenue. So expenses were 3/4 of the revenue. Again, the same story. You would have revenue minus cost is profit. So revenue. So you just have to get cost in terms of revenue. So cost is revenue minus profit. So revenue. So sorry, gotta have cost here. Okay. So then from here, what you can have is profit is revenue minus cost, which is 3/4 of revenue. So profit is revenue over 4. You have to get this expression, profit over revenue. Profit is the revenue over 4. Revenue is just revenue into 100. So that means you will get the answer. So D is the answer. Okay?
Yeah.
Yeah. The second one was okay. So you get, I think, 25%. And
Yeah.
the first one was, where did I make a mistake here?
It was just the processes were the same. If you know two things, you would know. If you know the relationship between two things, you would know the relationship between everyone.
I missed the revenue. I got confused with the revenue and the C. That the C part was a new thing. So can you please explain the first part once again? That would make it clear to me.
So it said that profit was 1/3 of the cost, and the profit is revenue minus cost. So that means 1/3 of the cost is revenue minus cost. So revenue is 4/3 of cost, right? So if I'm making 1/3 of my expenses, that means my revenue has to be 1 plus 1/3 of my expenses, right? That is why I will make 1/3 of my expenses. Like if you are making 20%, if you are earning 20% of your cost, then your revenue has to be 120% of your cost.
So the revenue and the cost. So revenue minus cost is the profit. And here profit is 1/3 of the cost. Okay, so these are the two things where I made the mistake.
Okay.
Yeah, okay, I got it. Thanks.
Okay. Okay. Okay, let's do this. Okay, did you guys get the answer?
I think it's C. I got the answer.
Priyanka, did you get an answer?
C.
Okay. Says what fraction of this year's students are males? So you have two things happening here. You have transfer from another college and you have males and females. So let's always draw that table whenever you have such kind of bifurcations. You have males and you have females and you have transferred from another college and this college. Of this year's graduation students, 35% of male and 20% of female transferred from another college. So if you had M males and F females, 35% of the males, 0.35, and 20% of the females, 0.20, transferred from another college. And the question is asking what fraction are males. So what fraction are males? This will not give you the answer because you don't know what fractions are males. Okay, so let's see the second statement. Of this year's graduation students, 25% transferred from another college. This itself is insufficient. I'm going to combine both of them. It says that of this year's graduation, 25% transferred from another college. So this is M plus F. 25% transferred from another college. So that means 25% of this. So this is M plus F over 4. So this plus this is equal to this. So 0.35 M plus F over 5 gives you M plus F over 4. So let's see what is happening here. So this is 0.35 M minus 0.25 M is F over 4 minus F over 5. So this is 0.10 M is equal to 0.05 F. So you have M over F. If you have M over F, that means you know what fraction, what is the ratio of males and females in the college. So that means by combining you can get the answer. Did you guys understand what happened here?
Yes.
Yeah.
Okay, so yeah, so always draw this table. It's actually very, very useful technique. Let me give you another question using this table. I teach this in set theory, but we can do a little bit of this here as well.
Actually, I didn't do the full calculations, but in the first thing, I just took like M plus 35 by 100 M, and so I just took the total in both the statements when I combined, and then I just concluded that it is C.
Yeah, I mean, always try to do the whole calculation. That will actually help you a lot.
Okay. Yeah.
Yeah. Okay. Okay, so yeah, I'll cover that in set theory. Let me cover another concept, which is a very easy and a very scoring concept. That is the concept of rates. We have covered up a little bit of it in averages as well, a little bit of it in percentages as well. But sometimes you will get questions based on rates, like if you can do a job in these many days, if B can do a job in these many days, then this happens and then that happens. Now understand in that, uh, always try to use this. Whenever you see a rate question, you always write work done is equal to rate into time. And you solve the question in a tabular format. Now, let's suppose if A can do a job in 3 days and B can do a job in 5 days, I'm asking you how much time it takes for both of them to do the job. Now, what you can do here is you can actually assume your own work. And sometimes you have to put a variable in it. Sometimes you don't have to put a variable in it. That is completely your choice. And that depends on what is the context of the question. This is something that we will do in practice. But what you can do is you can actually assume your own work. Let's say that the work is of 15 units, preferably the LCM of these numbers. So, and again, fill up all the information that you have. So A can do the job in 3 days, B can do the job in 5 days. Let's say the total job is of 15. We want to know how much time will they take together to finish the job. Now, if you can do a job in 3 days and the job is of 15 units, that means you will do 5 units per day. He will do 3 units per day. Now, this is where it gets easy. You can easily add the rates. That means together they will do 8 units per day. And how much time will it take for them to finish 15 units? That is just 15 by 8 days. Is that fine, guys? Are you understanding this?
Yes.
The whole thing depends upon just this thing. Assuming your own work, filling up the rates, and just solving the question. Right? Now, this is where you have individuals working for you. What if you have groups of people? Let's suppose you have 10 men working. Right? And in here, what you can do is you can make an assumption. You can make an assumption that assume that one man working in 1 day finishes 1 unit. If you make that assumption, then 10 men can finish a job in 5 days actually means that the total work is of 10 into 5, which is 50 days, 50 units. So if M1 men can do the job in D1 days, which is the total work, then M2 men will take D2 days, which is the total work. So if 10 men take 5 days, then 5 men will take 10 days because the total work is of 50 units. Now, if you have two different type groups, let's suppose you have 10 men and you have 5 women. And now here you are again making an assumption that one man takes 1 unit of work in 1 day and one woman finishes her own 1 unit of work in 1 day. And a one man's unit is not equal to a one woman's unit. This could be greater than that, or this could be greater than that. So in here, if 10 men takes 3 days to finish the job and 5 women take 2 days to finish the job, that means the total work is of 30 man units. And the total work here is of 10 women units. That means they're equal. That means 3 man units are equal to 1 woman unit. And from there, in this, you just solve the question in its context. You guys getting what I'm doing here?
Yeah.
Lakshmi, did you understand?
No. Can you come again? The second part, multiple men, multiple people.
So when you have multiple people in the group, different type of people, then their units are not going to be the same. Don't make that assumption. Just make that assumption that every person in the group is identical, and within a group they finish 1 unit every day. Just make that assumption. Don't make that assumption that one man is equal to 1 woman. Don't make that assumption because that is why they've been given differently in the question. So, and if 10 men can finish the job in 3 days, that means the total work is of 30 men units. And if 5 women can do the job in 2 days, that means the total job is of 10 women units. And they're equal because the work is the same. Everything will revolve around the work being the same. If you can finish the work, that means that you have done the same amount of work. And the whole question works around that. And always, whenever you see a question, write work done is equal to rate into time. In individual, in other ones, you can, you can just use this, that the total work is this, and then the question will give you some context, and you just have to fill yourself in that concept. Okay, shall we see some questions?
Yes.
Okay, I'm going to solve the first question, and then I will give you how to solve it. Okay, let's see this question. So this question says that machine A and B can produce one widget in 3 hours. So you have work done is equal to rate into time. So machine A and B can produce one widget in 3 hours. So they both are working at their respective rates. If machine A's speed was doubled and two machines could produce one widget in 2 hours, how many hours does it take to A? So what you will do here is you will first just put down the information that is given to you. So when A and B are working together, so if A works as well as B works, and I'm going to assume their rates. Let's say the rate of A is A, the rate of B is B. Let's say the A finishes this many units per hour, B finishes this many units per hour. If they both work together and they work for 3 hours, then they finish the whole work, because A and B can produce one widget in 3 hours. And so that means if they work for 3 hours, this is the rate. That means this is the amount of work that they have finished. If machines A speed were doubled and the two machines could produce one widget in 2 hours, so they will take them 2 hours if they do it at this rate. So what is the total work now? The total work is 2 into 2A plus B. Is that fine, guys? What is happening here?
Yeah.
So what would be the next logical step?
Add.
What is the condition here? What is something that I can equate?
Their respective rates.
Come again? The work is the same?
Yeah.
Because you're still finishing one widget, right? So that means this is equal to this. That means 3 times A plus B is actually equal to 2 times 2A plus B, right?
Yeah.
So let's solve this. So 3A plus 18 is equal to 4A plus 12. Sorry, not 18. 3A plus 3B is equal to 4A plus 2B. So that means from here I get B to be equal to A, right? Simple as that.
Yeah.
So if I get A to be equal to B, now just to reiterate this, it will take 3 hours working at 2A units to finish the whole job. Now the question is asking, how many hours does it take for machine A to do the job? If machine A does the job, then machine A's rate is just A. If it's working at 2A, it takes 3 hours. Working at A rate, it will take 6 hours. Fine?
Yeah.
So the key to the question was this table, and assuming the rates and equating the work. That is what was key, and that will be the key to every work and rate problem. Okay? Okay, let's see some problems. Okay, why don't you guys solve this? Did you guys get the answer?
2700.
Lakshmi Narayan, did you get the answer?
No, I'm kind of confused. I think you need to tell me again.
Okay, so work done is equal to rate into time. We will start with that. A copy machine working at a constant rate makes 35 copies per minute. So that's the rate. A second copy makes 55. So if they both are working together, they will make 90 copies per minute. And how many copies they do in half an hour? So in 30 minutes. How many copies two machines can make in half an hour? Is that fine? So how many copies do they make? 2,700? Did you understand this?
Yeah. Answer options. Okay.
Yeah, first job is to lay down everything that is given to you in the problem and then start figuring out which holes to pick. Okay. Lakshmi Narayan, is that fine?
Yeah, now I got it.
Okay. Let's see this problem does. Let me know if you guys are done. Are you guys done?
I got 4/9.
Okay. Lakshmi Ryan, did you get in the answer?
I know I got 1/3.
Okay. So work done is equal to rate into time. Tom alone can paint the room in 6 hours. So if Tom alone works, he can paint the room in 6 hours. Peter and John working independently. So it's working independently. Can paint the room in 3 hours and 2 hours. So Peter can do it in 3 hours and John can do it in 2 hours. Okay. Let's assume the work. Let's say the work is of 12 units. Okay. So the rate here is 2, the rate here is 4, the rate here is 6. Okay. So Tom starts painting the room and works for it own for 1 hour. So for 1 hour, Tom works. Tom's rate is 2. He finishes 2 units. Then he is joined by Peter and they work together for 1 hour. So Peter and Tom. What is Peter and Tom's rate? It's 6. And they work for 1 hour. So they finish 6 units. And then John joins them and 3 of them work together to finish the room. So Peter, Tom, and John. So what is the rate together? The rate is actually 12. And how many units are left? The units that are left are actually 6 and 8. 4 units are left. So they will take 1/3 of the hour to finish the job. Is that fine till now, guys? I've just laid down the problem.
Yeah.
Lakshmi Narayan, is that fine?
Yes, but I did it in a different way.
Mm-hmm.
I took it like 1/6 of the work done by Tom, and then the next hour 1/6 plus half done by Tom and Peter.
Okay.
And then the next hour, the hour by hour I did. I mean, it was a tedious calculation.
You could have just assumed the work to be 12 because what you did was you assumed the work to be 1 and then you end up with fractions, right?
Yes, and that was messy.
Yeah. So the question says what fraction of the whole job was done by Peter? So Peter worked for 1 hour and 1.5. Peter actually worked a total for 1 plus 1/3 hour. So he worked a total for 2/3 of the hours, right? Sorry, 4 by 3 hours. So in 4 by 3 hours, how many units he will finish? If he finishes 4 units every hour. So if he finishes 4 units every hour, he will finish 4 by 3 into 4. He will finish 16 by 3 units. And what's the total job of? The total job is of 12 units. So what fraction of this is this? That is 16 by 3 into 12. So this is 4 times 3 and 4 times 4. So the answer is 4 by 9. Is that fine, everyone?
Yes.
Yeah.
Lakshmi Narayan, is that fine?
Yes.
Okay. Okay, let's see this one. Let me know if you guys are done.
E.
Okay, Lakshmi Narayan, did you get an answer?
Even I'm getting C.
Okay, so A can do a certain job in X hours. So you can plug in here or you can choose not to. Uh, so machine A can do a job in X hours, B can do the same job in Y hours. If A and B work together, which of the following represents the fraction of job that B will not have to complete? So basically the question is asking what fraction of the job does A complete, right? Let me assume that the total work is of XY units, then A finishes Y units, B finishes X unit. So A does Y units per hour and B does X units per hour. Together they do X plus Y units per hour, right? So what fraction of the job does A do? A does Y units out of X plus Y units. So the answer is Y over X plus Y. Do you guys understand?
Yep.
Lakshmi Narayan, did you understand this?
Yeah, I totally did it in a different way.
Mm-hmm.
Somehow I got the answer wrong also.
Okay. So what did you do?
So again, I rate into time equal to W, but I took W as 1 again.
Mm-hmm.
So, but you took as XY, and then I had I kept on adding, and I ended up with some X plus Y upon X1 minus 1 by X, and then kept on solving.
Yeah.
But basically, this was not correct.
Yeah. I mean, questions are easy. I mean, we make it difficult for ourselves. So, yeah. I mean, don't never assume the work to be one. One is like the most basic way of assuming work. Try be a little creative there. Huh? Okay.
Sure. I need to practice this questions one, so I will have a hold of it.
Okay. Let's see. Okay. Let's see this problem. Let me know if you guys are done. Did you guys get the answer?
I got B. I don't know.
Okay. Priyanka, did you get the answer?
Not completely sure, but D.
Okay. So work done is equal to rate into time. So let's just fill in all the information. If both work at their normal rates, they'll finish the job in 45 minutes. So Maria plus Perry, they work together, they will finish the job in 45 minutes. Let's keep it 45 here. And if Perry were to work at twice the Maria's rate, so Maria plus twice Maria's rate, they'll finish the job in 20 minutes. How long would it take to Perry to finish the job alone? So the question is asking, how long will it take if Perry works alone? Let's assume that the work is of 180 units, right? And so the work is of 180 units, then you can clearly see that you can get the value of M. What is M? 3 times M into 20 is 180. So 3 times M is equal to 9. M is 3. So if M is 3, then you can get the value of P from here. 3 plus P into 45 is 180. This is 45 times 4, so P is 1. So if P is 1, how much time will it take to finish 180 units? 1 hour. Sorry, 180 minutes, which is 3 hours. So the answer is E. Did you guys understand this?
Now I did.
Okay. Priyanka, is that fine with you?
Yeah, that's good.
Okay. All right. I think I think I've covered everything that I was supposed to cover today. just to summarize, what I did was percentages and rates. So in percentages, we did the application of percentages, but the overall story was, if you change something by A%, this is what happens to it. And that's the applications of this were in interests, in profit and loss, and progressions. And then we did rates. In rates, all you have to do is you have to write work done is equal to rate into time, fill in all the information, assume the work if you need to, assume the rate if you need to in terms of variables, and then just the question is very, very contextual and depends on the way the question has been asked to you. So do you guys have any questions for me on this?
So in the previous question, you took 180. So it was just a guess, or did you have some calculated value?
So I had 45 and I had 20. So a number that is divisible by both. So I took 180. LCM of 45 and 20.
Okay.
Yeah. So you don't want to end up with fractions. If you end up in fractions, we are going to make the question difficult. It will be your self-created difficulty, but the question is not difficult.
I did the equations exactly like you did, but again, I ended up with some wrong values of work.
Okay. Yeah. So try having a habit of trying to find out if you can assume the work.
LCM would always work, right? That was the best thing to do.
Yeah, I mean, always you can assume your work, and for rates you can choose variables to put in there.
Okay, I'll practice, and I think here I need to work on it. I'm not getting answers correctly here.
Yeah, I mean, if you actually diagnose what you're doing is you're not assuming a comfortable number for work. We're assuming.
Yeah, all three questions I did the same mistake. Twice I assumed one, and this question I didn't assume 180, which was the easiest thing to do.
Yeah, and that is a creativity that you'll have to bring, and that'll come with practice. Yeah.
Sure.
Yeah. So I will upload work questions and percentages questions, and I will re-upload the inequalities questions as well. Okay.
Okay.
Yeah, and if there is any question, I'm available throughout the week. Let me know. And I hope you guys would be taking a practice test soon.
Yeah.
Yeah. So.
Yes, maybe next week. Yeah.
Yeah. Okay, so I will end the session then. Thank you very much. Yeah, thank you. Thank you, Lakshmi Narayan. Thank you.
Thank you, Pushpa. Thank you very much.
Have a good one. Okay, bye.